Okay, this is section 5.2. So I just handed out the PowerPoints with some of the important stuff on it. Let's kind of go through here. I'm just going to hit the high spots on the PowerPoint. We are talking about evaluating different points on the unit circle at different terminal stops. We talked about terminal points versus reference points last time, and here we see on the trigonometric functions, t is where we end up. We always start, always at 1, 0. Okay, if our t is positive, we go counterclockwise, we go up. If it's negative, we go down. Now, definition of trig functions, okay? We have sine of t is y. What this is telling us is that anytime that we are asking for the sine of a terminal point, it's going to be the y coordinate. That's what they mean. Okay, I think this is on your handout. The cosine of t, okay, is x. Cosine is your x coordinate. So anytime you see these ordered pairs, we've been picking out the ordered pairs now for all of section 5.1, the x coordinate is going to be the cosine at that terminal point. The y coordinate is going to be the sine at that terminal point. Okay, and tangent, we know these from way back in geometry. Tangent is sine over cosine. Okay, so it's essentially your y coordinate over your x coordinate, because it is sine over cosine. So now let's talk about the, I hate to say the inverse, the reciprocal functions. Okay, cosecant is the reciprocal of the sine function. So literally, if you are trying to find the cosecant of something, you will notice on your Casio calculator there is no cosecant button. Okay, unless you all have some newfangled one, I don't. But what we have to do is we have to find sine, and then you all know on your calculator, everybody has the little x to the -1 button. Does everybody see that? Okay, what you're going to do, if they ask you to find the cosecant somewhere, you are going to do sine of that same number, hit equals, and then immediately leave the answer in your calculator. You're going to hit the x to the -1 button to get the reciprocal of it. Because what does -1 do? You all remember? Maybe it flips it, that's right. So if we have the x to the -1 button, what that does for us is essentially flips it and puts x on the bottom. Okay? So again, most calculators do not have cosecant, secant, and cotangent buttons. You have to remember that cosecant is the reciprocal of sine. We now have an announcement. Okay, remember that secant, you're going to have to remember that secant is the reciprocal of cosine. And you're going to have to remember that cotangent's the reciprocal of tangent. So if you know those reciprocals, pairs, if you will, then you can just find the tangent of t and hit the x to the -1 button in your calculator. Okay? It's the reciprocal of that. Okay. Find the 6 trigonometric functions for each given real number t. I don't think you guys have this in what I handed you, because I wanted to do this together as a class. So t is pi over 3. You all still have your chart, though. I see everybody turn on their chart. That's awesome. So we need to find the 6 trig functions for that spot. So sine of pi over 3. Now, on that table that you had, and it's in your handout, what, first of all, is sine x or y? Sine is y. So if you look on your unit circle chart, I'll just put in a couple of them. Okay, this would be like pi over 3, right? What's the ordered pair for pi over 3? Okay, that's the ordered pair for pi over 3. So sine of pi over 3, sine is your y. So that is root 3 over 2. Okay? Cosine of pi over 3, that's your x coordinate. What's that going to be? 1/2. Okay, it's the x-coordinate from the same ordered pair here. All right, all 6 of these can come from that one ordered pair. All right, what would tangent of pi over 3 be? Now, tangent, remember, is sine over cosine. So essentially, we're doing a little math here. Root 3 over 2 divided by 1/2. And of course, that's a dead spot on my board. So if we do this, this is root 3 over 2 times 2 over 1, right? I mean, you could poke it in a calculator, but, you know, we're big kids. We can do it in our head. This is root 3. Okay, just doing the math. Sine over cosine. The 2's cancel. Everybody still with me? This, yeah, in my dead spot, that is a root 3. It's root 3 over 2 divided by 1/2. If you divide by 1/2, you multiply by 2 over 1, the 2's cancel. Okay? Cosecant. Cosecant of pi over 3. Oh, these dead spots are really bugging me. Cosecant of pi over 3. Cosecant is the reciprocal of sine. So if sine is root 3 over 2, what would cosecant have to be? 2 over root 3. Now, can we leave something with the radical on the bottom? Nope. So we would have to rationalize the denominator. You all know how to do this. You may not remember, but we did learn it. So multiply top and bottom by root 3, you get 2 root 3 over 3. That's cosecant. Okay? I'm running out of room, so let me move over. What's the next one? Secant. So secant of pi over 3, secant is, yeah, they're here on the chart, but I'm showing you why. Secant is the reciprocal of cosine, right? So what is cosine? Cosine's 1/2, so secant would be 2 over 1, or just 2. Cotangent of pi over 3, again, is the reciprocal of tangent of pi over 3. So instead of it being root 3, it's going to be 1 over root 3, which then we know if we rationalize it is root 3 over 3. And again, you've got this pretty little chart on page 12 of the handout. Okay, did everybody understand the process here? Okay, all right. Let's keep going, obviously. And they go, oh, I don't want to do all of these. Come on, come on, come on. I'm not going to do the pi over 2. Those are really easy. You all realize, though, pi over 2 is straight up and down, right? So pi over 2, if we have our unit circle, this is pi over 2, right? What we have to be careful with on the pi over 2s, the pi's, the 3 pi over 2s, what we have to be careful on all of these is some are 0, right? The x-coordinate of pi over 2 is 0. So what do you think is going to happen when you try to take the reciprocal of that? It's not going to work, okay? It's going to be undefined. Remember the reciprocal, so let me leave this up here for a minute. So again, sine of pi over 2 is 1. Cosecant is its reciprocal, right? So the reciprocal of 1 is still just 1. Okay, the next one here, cotangent. Of course, it ran into my... I don't know why they're doing them in this order, but cotangent, remember, is sine over cosine. Oh, sorry, that's tangent. Cotangent is cosine over sine. So 0 over 1 is 0, so that works. Okay, that's why they're doing them in this order. Now I see, because these are all the ones that are defined. What happens on some of the rest of them? What happens on secant of pi over 2? Again, that's what we were just talking about. 1 over 0 can't happen. Okay, what happens to tangent of pi over 2? Again, it would be 1 over 0, can't happen. Okay, so it says tangent of pi over 2 and secant of pi over 2 are undefined because x is 0 and you can't have that in the denominator. Okay, so those are, you'll notice on your little chart, they're on page 12 again, they've got little dashes, okay, where they are undefined. And the next section we get to in 5.3 is going to show you actual trig functions. They're graphs, and so you'll see a little more. But again, this chart right here is going to be your friend. I have another unit circle chart that I will give you probably Wednesday. But this will be your friend for now, okay? So the rest of this lesson really focuses on identifying where your terminal point ends, what quadrant you're in. We did some of this on Friday, right? Or Thursday. What quadrant you end up in so that you know whether it's positive or negative. Domains of trigonometric functions. This is important to note, and this should be one on your sheet. Domains. What's a domain? The x value, like the input, right? So remember, your domain in a function is your input value. So for sine and cosine, it's all real numbers. Okay, anything works. Why is that? Because you're just going to keep oscillating. Any number you put into sine or cosine is going to either give you anything from a -1 to a +1. Okay, it just works. Tangent and secant, that's like the one we just did with the 0. Okay, it's all real numbers other than pi over 2. What do you think they mean by this n times pi here? Any number times pi. So if you have the unit circle here, again, this is pi over 2. Whatever's undefined at pi over 2 is also going to be undefined at 3 pi over 2. It's also going to be undefined at 5 pi over 2. Okay, at 7 pi over 2. As many times as you go around, it's going to be undefined at all of those. Does that make sense? That's why they put the little plus n pi. So at both of these points, remember your x-coordinate is 0, so that affects your cosine and therefore your tangent. Okay, so those are undefined there for the secant and tangent. And this one, cotangent and cosecant, okay? This is all real numbers other than n times pi. Well, think about this. Let me put this one up here, okay? For cotangent and cosecant, if we are here at pi or 2 pi, okay, what is the value of y? 0. So can we take the reciprocal? No, so that's why. So this one is because, let me write this up here. That's because your x equals 0. Again, dead spot, that's annoying. And this is where your y equals 0. Okay, so that means every pi, you can't take cosine because your y would be 0. Okay, or you can't take cosecant, sorry, cosecant and cotangent because y would be 0. That would be in your denominator. Okay? Everybody okay with that? Kind of. Again, this will make more sense as we use it. Okay, so value of trigonometric functions, we're going to dive in. We have already seen this, but in our quadrants, okay, all of 4 quadrants here, all the trig functions are positive in quadrant 1. Okay, so sine, cosine, tangent. Really, I only really think about the main 3. Because if sine is positive, what's the sign of cosecant going to be? Positive. If something's positive, its reciprocal is still positive. If something's negative, its reciprocal is still negative. Okay, so I really only worry about the main 3 trig functions. Quadrant 2. Now again, keep in mind that your x-axis is really your cosine. Your y-axis, dead spots, is really your sine. Okay, so in quadrant 2, what trig functions are positive? Sine. I'm just looking about the main 3. Okay, sine is positive, which means it's, dadgummit, these dead spots are killing me. Which means that, of course, its reciprocal is also positive. Okay, in quadrant 3, okay, tangent is positive. Okay, and that's the only one. Why? Because sine and cosine, x and y, are both negative in the 3rd quadrant, right? Because remember, our ordered pairs, we have positive, positive, we have negative, positive, here we have negative, negative, here we have positive, negative. Okay? So, tangent, because it's sine over cosine, that's x over y, 2 negatives make a positive. That's why tangent's the only one that's positive in the 3rd quadrant. Fourth quadrant, cosine is the only one that's positive. Okay, because again, cosine is your x value. If your y value is negative, that's going to make your tangent negative. Okay, because again, tangent is y over x, sine over cosine. Now, here's a little thing to help you remember. All students take calc, and I didn't make that up. But one way to try to remember which trig functions are positive in which quadrant is if you kind of go around counterclockwise here in the direction that we would be going around our unit circle. All students take calc. All of the trig functions are positive in the first one. Sine is positive in the second. Tangent is positive in the third. Cosine is positive in the fourth. And again, I'm just talking about the main three. Because if you know the main three, the rest are easy. We okay there? Okay. Evaluating trigonometric functions for any real number. Here's the steps. Find the reference number. We talked about reference numbers. Okay? Remember, reference number is whatever quadrant you're in, the shortest distance to the x-axis. That's your reference number. Okay? Find the sign. Determine what quadrant you're in so you know whether cosine, sine, or tangent are positive or negative. Then find the value. You can use your handy-dandy little chart. Everything really refers back to the values from the first quadrant. You just have to know what quadrant you're in to know whether they're positive or negative. And again, we did some of this last week. So for instance, I'm not going to spend a ton of time here, but cosine of 2 pi over 3. Where on the unit circle is 2 pi over 3? First quadrant, second quadrant, third quadrant, second quadrant, right? 2 pi over 3 is like somewhere around in here, wouldn't it? Okay? So, 2 pi over 3, and this is cosine. So first of all, well, let's just say, what's our reference number? So our t, do y'all remember how we found reference number last time? If our t is 2 pi over 3, so our reference number, I want to say r, and that's not how they did it. They did the little t with the vertical bar. So our reference number is just pi over 3. Would you agree? Because this right here is your reference number. That's your reference number. Okay, shortest distance down to the x-axis. So from 2 pi over 3 to pi is just 1 pi over 3. So, but it's in the second quadrant, which makes cosine positive or negative? Negative. So really what we're looking at is negative cosine of pi over 3. That's going to give us our answer. Well, what's the cosine of pi over 3? Look at your chart. What is the x value of the ordered pair at pi over 3? X value of the ordered pair at pi over 3 is? X value of the ordered pair, 1/2. So this is actually negative 1/2. Okay, figure out where you are on the unit circle, what quadrant you're in, find your reference number. Based on the quadrant, you know that your cosine is going to be negative. Okay, and then just use your reference number and your values from the first quadrant. Tangent, negative pi over 3. Okay, now, negative does what for us? It goes down, right? So like here would be negative pi over 3. So again, what's the reference number there? Just pi over 3, right? So our t, the terminal point was negative pi over 3. Our reference is just positive pi over 3. But what is the sign of tangent in the fourth quadrant? Tangent's negative, right? Because the only, remember the all students take calc, the only trig sign that's positive in the fourth quadrant is cosine, and then by default it's reciprocal secant. But tangent's negative. So really what we're looking at is negative tangent pi over 3. Well, we just found that a little bit ago. Or on your chart, what is tangent of pi over 3? Root 3. So this is actually negative root 3. Remember, tangent is sine over cosine, so you would actually be taking your, like, root 3 over 2 divided by 1/2, which is just root 3. Now, this one's a little tricky. Okay, 19 pi over 4. Holy cow. What is 19/4 as a mixed number? 4 3/4, right? So this is 4 3/4 pi. Now, think about this for a minute. Oh, I hate my dead spot. So this is 2 pi, 4 pi. So what we're really looking at is over here. Okay, so really this 4 3/4 pi, subtract off, oh my gosh, these dead spots are killing me. Subtract off the 4 pi. So 19 pi over 4 minus 4 pi would give you 3 pi over 4. Why am I taking off the 4 pi? Because that's 2 full circles of the unit circle, 2 revolutions. I'm just subtracting them off because they didn't change anything. I just made 2 complete passes again. 1 pi, 2 pi, 3 pi, 4 pi. So take that off. What I'm left with is 3/4. So I'm left like right there. You guys with me? Okay, so what would be my reference number then? Pi over 4, right? Pi over 4. So again, terminal point might have been 19 pi over 4. My reference number is just pi over 4, but it's in the second quadrant, okay? So in the second quadrant, what can we say about sine? Is it positive or negative? It's positive. So really all we're looking for is sine of pi over 4, which is what? Remember, the pi over 4s are the easy. They're always going to be root 2 over 2. Are we okay? I know this is tricky, and I promise we're going to do a ton of these, so you'll get it. Of course, they have pretty little pictures. These are all posted on Google Classroom. I didn't print all of these. Now, this is a biggie I wanted you to see. I'm not sure I printed this, but when the Casios are really good, the Casio calculators that we use here are really good about giving you the actual, like, radical fraction that you need for an exact answer, where TIs won't. Like, they'll give you the answer root 3 over 2 if you put it in the right mode. Here's the key right here. The calculator must be put in radian mode to evaluate the functions. So if you are going to be calculating, if you're going to be putting in sine, cosine, tangent, you have got to be putting in your calculator in radian mode. Now, what that means is you do the shift, let me look, it's the shift mode, so you want to do setup, and then I forget what number it is, 3 or 4? Okay. So then you hit 4, and then you hit enter, and then you can clear it out, and then you're in radian mode. Okay. Now, on the TIs, I can't tell you. I don't know. Everybody's a little different. The Casios, again, you want to shift setup. Yeah. Okay. Quick way to, up in the display, it'll have an R or a D. D is degree mode, R is radian mode. I'm so blind I can't tell the difference, so I just put it in there regardless. So one way to check yourself is to put in something like, put in sine of pi over 2. Hit the sine button, and then literally put pi over 2 in your sine function and hit equals. Actually, let me change that. Make that pi over 4. Sorry, make that pi over 4. So sine of pi over 4, what does it give you? It gives you root 2 over 2. Okay? And again, this is just a reminder that the cosecant is the reciprocal of sine, secant's the reciprocal of cosine, and cotangent's the reciprocal of tangent. Okay. Now, when you're in radian mode, you can also literally just put these in, like the sine and cosine on your homework today. They're going to tell you how many decimals to round to. If they don't give you the terminal point in terms of pi, then they're going to tell you what to round to, because you have no choice but to get a decimal answer. Does that make sense? Okay. So if they give you the terminal point in terms of a decimal, they're going to tell you what to round the answer to. Now, cotangent of 28. Here's how you would put that in your calculator. I said this earlier, but I would literally put in tangent of 28, hit equals. Again, make sure you're in radian mode. But then once you get your answer, what is that? Okay. Now, to get to cotangent, I leave the answer in there. So then you're going to have a and s and then x to the negative 1. So hit that, leave your answer in it, hit the x to the negative 1 button. And what does that give you? Yeah. Okay, that's how you quickly find the reciprocal. That's how you use that x to the negative 1 button. You have to know your reciprocal functions. Again, I remember them because the reciprocal of sine that starts with an s, its reciprocal starts with a c. It's cosecant. The reciprocal of cosine, which starts with a c, its reciprocal is secant, which starts with an s. They flip-flop. That's how I remember which one is which. Okay? Cotangent and tangent are, they both have the word tangent in them, so. Okay. Too much gibberish, Kellen says. Okay, I now want to pull up your homework because I think we're going to be, oh, no, there's one more thing. Even and odd. Did I copy this? Okay, even and odd. This is a biggie. You all remember even functions? If you have an even function is if you put f of negative x in and you get f of x back out, that's an even function. Like if you can substitute in a negative x for your x and the function stays identical, that's an even function. What does that mean? It means it's symmetrical, it's graph about the y-axis. That's what that means, essentially. An odd function. An odd function means if you put in a negative x, it makes the whole function negative. Okay? So I don't know if you all remember, we did these in Algebra 2. If like every variable in your polynomial is even, then it's an even function. Okay? Because whether you put in a positive or negative x, it's not going to matter. Okay? If every variable in your function is odd and you put in a negative, it's just like the whole function turned negative. Okay? So this is telling us even and odd functions. Cosine is even. Okay? Cosine is an even function. Which means whether you put in a positive 1 or pi over 3 or a negative pi over 3, doesn't matter. You're going to get the same answer. Why is that? Because again, cosine is your x-axis. Okay, when you put numbers in the calculator, they're thinking they're in the first or second quadrant, generally speaking. So if you're talking about the x-axis, then if you're putting in, wait a minute, yes, sorry, I misspoke there. Even function, you're putting in a negative t, you're getting out t. Sine of negative t equals negative sine t. That's an odd function. Tangent is an odd function. I know. Okay, those are kind of important to remember because it can make our life a little easier. If sine is an odd function, if I'm putting in negative pi over 6, this is going to be the same thing as negative sine of pi over 6. I can just pull the negative out because I know it's an odd function. Cosine, since it's even, I know that negative pi over 4 is the same as positive pi over 4. Okay? And I misspoke earlier when I said first and second quadrant. I meant first and fourth quadrant. So again, think about this on your unit circle. So a negative pi over 6, if we're going down to negative pi over 6, sine is your y-axis. So that would make sine negative, wouldn't it? Whereas cosine, negative pi over 4, down here, cosine is positive in both of these. So that's why it doesn't matter. Okay, so whether you're putting in the positive or whether you're putting in the negative, it's going to give you the same answer. Okay? All right. Oh, everybody okay so far? We're going to do some of your homework problems now. Okay. Let me get to homework here. So it says, find the exact value of the trigonometric function at the given real number. 4 pi over 3. Again, here's how I do these. Think unit circle. Where is 4 pi over 3? This is like 4 and 1/3 pi, right? Yeah. Whoops, it would actually be down here a little more, but it's down in the third quadrant. Okay? So in the third quadrant, is sign positive or negative? It's negative, right? All students take calc. So we have negative sign of, what's the reference number for 4 pi over 3? Just pi over 3, okay? So you can check your chart in your thing. What is sine of pi over 3? So in this case, it would be negative root 3 over 2. Does that make sense? You guys with me? Okay. So again, this chart will be your friend. You just have to figure out whether it's positive or negative. Okay, cosine. So these are all the same. So they all deal with the same position. The third quadrant, okay, is cosine positive or negative? Negative. So again, this is the same thing as saying negative cosine of pi over 3. Same thing. What would that be? Tangent of pi over 3. First of all, is tangent in the third quadrant positive or negative? It's positive. It's the only one that's positive, right? So this is the same thing as asking about tangent of pi over 3. Well, what's tangent of pi over 3? Root 3. Are we okay? Same kind of deal. Let me just... Okay, let's look here at number 3. Because they're all signs, but they're all over the place. So first of all, 7 pi over 4. What quadrant is 7 pi over 4 in? Fourth, right? This is pi over 2, pi, 3 pi over 2. This is like 2 pi, so we're almost there. This is 1 3/4 pi, right? So we're 1 3/4 the way around the unit circle. So fourth quadrant. Is sign positive or negative in the fourth quadrant? Negative. So this is minus sign of what would be the reference number? Just pi over 4. So what would that give me? Negative square root 2 over 2. Good. Now, 9 pi over 4. Again, what is 9 over 4 as a mixed number? 2 1/4 pi. So again, on your unit circle, you go all the way around, and then you go 1/4 more. Okay? So again, it's the first quadrant. Everything's positive, right? So this is just going to be root 2 over 2. All of these are root 2 over 2 because they end in a 4. Okay? It's just a matter of whether it's positive or negative. Now, 3 pi over 4. What quadrant is that in? Second. So we're going to get to about right there. Okay? So again, this is the same. First of all, is sign positive or negative? Positive. So this is sine of pi over 4. Positive. So again, root 2 over 2. Okay. Let me see if I can get to some more difficult ones. Yeah, let's look at this one. No. I want to get one that has like all of the... Actually, let's look at this cotangent one real quick. Find the exact value of the trigonometric function at the given real number. Okay, first of all, we're going to have to deal with these in terms of tangent first. So, on your unit circle, negative pi over 3 is like down here, right? Fourth quadrant. So, is tangent positive or negative? Tangent's negative. Tangent's only positive in the first and the third, right? So tangent's negative in the fourth quadrant. So this is the same thing as negative, I'm going to say, cotangent of pi over 3. Now, this is the same thing as negative 1 over tangent pi over 3. Okay? Actually, though, your little chart there actually gives you the cotangent, doesn't it? So what is negative cotangent of pi over 3? Yeah, negative square root 3 over 3. Okay. 3 pi over 4, what quadrant's that in? Second. Okay, 3 pi over 4 is here. All right. Second quadrant is cotangent, or let's back up to tangent. Is tangent positive or negative? Negative. So this is negative cotangent of, what's the reference number? Just pi over 4. Okay? So what is cotangent of pi over 4? 1, so this would be negative 1, right? Everybody okay? Seeing how this works? All right. I wanted to jump down to one that was a little weirder. Okay, let's talk about this one for a minute. Number 9, the terminal point P is negative 8/17 and 15/17. Okay, don't make this weirder than it is. All right, sine references what? Is it your x or your y? Sine is your y. So sine of t is your 15/17. What would cosine be then? Negative 8/17. Cosine is your x value. Tangent, how do we get tangent? Sine over cosine. So you're going to have 15/17 over negative 8/17, which is 15/17 times negative 17/8. So again, those cancel. You're going to end up negative 15/8. Probably not. Kaya asked if it would take it if we just put the improper fraction in. I don't know. I say probably not. It might, but you all are smart enough to not do that. Just know that if you're dividing, just cancel out the denominators. That's all you have to do if they have the same denominator. Okay? There was one that had like all 6 functions that I wanted to look at. Okay, let's look at this one, number 12. Find the values of the trigonometric functions of t from the given information. Now it tells us cosine t is negative 15/17, and it tells us it's in quadrant 3. First of all, right off the bat, quadrant 3, what is positive in quadrant 3? Tangent, and then by default, cotangent. Those are the only ones that are positive in quadrant 3. So the rest of these are all going to be negative. Okay? Now, they gave me cosine. How can I find sine? Do you all remember your unit circle? X squared plus y squared equals 1? So what is cosine, x or y? X. So this is negative 15/17 squared plus y squared equals 1. So somebody tell me what 1 minus 15/17 squared is. Poke that in your calculator. Y squared equals Okay. So, now, notice I dropped the negative. I dropped it because I knew I didn't need it there on the 15/17. So square root that, y is 8/17. That's our sign. Now, that doesn't tell us whether it's positive or negative, but we did that by knowing it was in quadrant 3, right? So sine is going to be negative. So sine is negative 8/17. Do y'all see how the game is played here? Now, tangent, again, is what? Tangent's positive. How do we find the value? Tangent is sine over cosine, right? So sine is negative 8/17 over cosine is negative 15/17. If you flip the bottom, the 17s are going to cancel. So you get 8/15. It won't be negative, it'll be positive. Are we okay? Cosecant is the reciprocal of what? Sine. Remember, they flip-flop SC. So cosecant is the reciprocal of sine. So this is just negative 17/8. You literally just flip-flop it. Secant is the reciprocal of what? Cosine. So instead of negative 15/17, it's negative 17/15. Cotangent is the reciprocal of tangent. So instead of sine over cosine, it's cosine over sine. You're literally just flipping. Now it's 15/8. Is that making sense? Okay. That might have been the last one I really wanted to make sure we did. And holy crap, my video is now like 40-some minutes long. Okay, I think that, oh, shoot, yeah, I think we're good. All right, I'm calling it good. If you guys have any questions, come holler at me. Emily, I hope this helps.